Start with a flow meter, and let me actually show you real quick. I'm going to go into the calibration side, and I usually just go left to right. So it starts with flow meter, then it goes to scrubber, and then you do reference gas. Technically, the flow meter can be completed whenever, but you have to do the scrubber before you do the reference gas. So what's happening is you want to zero the analyzer of CO2 before you go into the reference gas. So make sure you do the scrubber before this guy. But we're going to start with the flow meter, and I'll show them actually. I wanted to. So this is your 3-liter syringe. I'm sure you've used them a lot of times. You have the corrugated tubing, and then the adapter for basically the other adapter, which is this guy, and then it'll go into the flow meter. Do you guys know how a flow meter works? Do you care to know?
Go ahead and review
it. This is a turbine on its own, and then this is an optoelectronic reader on its own. Together, we get a flow meter. So that's what this guy is. So basically, this turbine, I'll pass it around. It has a little filament in the center that spins in different directions. So when someone is breathing out or breathing in, it'll spin one way or the other. The optoelectronic reader, and I'll show you guys, it has like little sensors here on the inside. So it has little sensors on the inside of the ring. So those little sensors on the inside, whenever you place the turbine inside of it, depending on if they're inhaling or exhaling, the turbine will spin one direction or the other. The sensors are disrupted, and basically they can detect which way it's turning. So if they're breathing in, they're breathing out, and then how often. So we use a 3-liter syringe to pump 3 liters of air through the turbine. The system should recognize that it's getting 3 liters. It's usually like 2.9899, something like that, or right above. But if there's a small error, the system will correct for it. And that's important because you want to make sure that you're doing the calibration for this one turbine, and then you test with that one turbine. You don't want to like do a calibration with this turbine and then test with a different turbine, because the system is recognizing the error of that one turbine. But yeah, whenever you pump 3 liters through, this guy should spin roughly 100 times. So it's really just the software recognizing that it's passing or failing. And then if you're at you're supposed to be getting 3 liters. If you're at 2.899 or 3.1, you would be failing. So it's a pretty small error. Any questions on how this works?
And if it's failing,
If it's failing, usually I would try a different turbine. If a different turbine keeps failing, then you might want to make sure that the reader is fine. Basically, I just tried a bunch of different turbines. If they all fail, it's probably the reader. If just one turbine fails, but then 3 others pass, then you know it's that one turbine that's messed up. So that's the easiest way to know.
What's the margin of error for an expired sampling line? How does it impact the tests?
Basically, you're not getting accurate readings of what someone is producing. So like the CO2 expired or O2 inspired.
Okay.
So you wouldn't be getting accurate readings for the subject is basically all it is. And also technically for the calibration, you'd probably fail it, indicating that you probably shouldn't run a test on the person because then the information wouldn't be correct. Yeah, so you want to make sure that you do get new sample lines before you start running the test. But it's just because you wouldn't be getting good samples from the subject. Yeah, sure you get one. That's why you do need a new sampling line. And then, actually, since we're in it, the sampling lines, what they do is basically when you're running a calibration. So when you're running this reference gas calibration, this gas is 0% humidified. Before it gets into the analyzer, it needs to have room humidity. So the material is called Nafion tubing. Basically, it just brings this air up to room humidity before it gets to the analyzers. And then when someone is breathing during a test, this guy is on the wind cap. So it'll be right here. Someone would be breathing like this. The sample that's being brought into the analyzers, before it gets to the analyzer, it needs to be down to room humidity. And when someone is breathing, it's 100% humidified. So it's just really sensitive to humidity, and that's why like they turn super brown as like when they're new, they're basically clear. So yeah, just try to take care of them as much as you can. Like place them in plastic bags if you can, and then just obviously we're in Hawaii, so humidity is probably insane all the time. But just try your best to like keep it away from.
To a
hot,
freezer?
humid. Not a freezer, but you could even do like something refrigerated slightly. Definitely not a freezer though. But yeah, just try to take care of them if you can, and they should last a little bit longer. But typically they last, I've been told, this around 6 months. It really depends on usage and an environment. So that's the sampling line. Sorry. I get tired of buzzing. I don't know if you guys do, but I'm going to go ahead and set up the flow meter calibration, and then I'll have one of you guys run it. Actually, do you guys feel to do it? I think it looks kind of the same as a FitMate one, right? Actually, no, because you don't use this adapter, right, for the FitMate? No. Okay, I'll show you real quick. Sorry, it's been a long time since I see a FitMate. So once again, optoelectronic reader. You have the turbine. Notice that they kind of both like get smaller on the front side. So this end is smaller than this end, and then the turbine, same thing. This end is smaller than this end. Basically, just plug the turbine in from the back and slot it in, and then it should sit on the ring perfectly. If it's not sitting on it correctly, like if it's slightly out, that turbine is probably not being picked up by the reader. So just make sure that it's sitting all the way onto that optoelectronic reader. But yeah, that's pretty much it. Just push it all the way in. From here on the back end, you'll need this adapter. The adapter is only for the calibration, but those little plastic rings that are sitting on the reader, sorry, the plastic extensions that are sitting on the reader, will line up with the adapter. So the adapter has little slots on it. Alright. It has little slots, and then those little extensions are on the turbine. Basically just line those up. There we go. And I usually just spin it to make sure that it's on. And then from here, the adapter will go into the other adapter that goes to this syringe. So from here, all we need to do is connect the flow meter onto the K5. And you're technically good to do the calibration, but since I know that we'll be doing the reference gas and scrubber, I'm going to go ahead and connect this guy. And that's pretty much it. From here, you go into flow meter, and then it'll ask you to start performing strokes in a second. So you tune. From here, you just pull all the way out, push all the way in, and you don't have to go at a certain flow rate. And it should also give you like how much is actually being analyzed and if there's a correction error for it. Now I want to say it's 6. So do we get a password button? From here, you could move on to the CO2 scrubber. But I'm going to take this apart and have one of you guys do it.
Again.
Yeah, so you'll want to use the wind cap anytime you're testing outdoors. And if you're going to use the wind cap, make sure you calibrate the flow meter with the wind cap on it. You don't have to use it indoors unless you're going to have like a fan in the room. And that's, let me take this off. Wait, how'd you get that? The scrubber calibration. The scrubbers usually last a year, so you'll have to replace these yearly. Over time, basically all that happens is CO2 or air is being moved into the tube, up the sampling line into the analyzer, and over time, just the rocks will start to like expire. That's really it.
Is that based off use or just like calibrate your 365?
Once again, this one is a lot with environment. So if you want to store these like same as the sampling line, just somewhere like dark, cool, that could help a lot with it. But yeah, this one is more environment as well. So sampling line, CO2 scrubber, and environment. O2 analyzer is more time. So that one's just about a year no matter what. And then the gas tank should last a few years unless you end up leaking it accidentally. Before you go into the calibration and then CO2 scrubber, go ahead and plug it in because as soon as you press on the tile, it'll go into the calibration. Sampling line will go onto the top port here, so just place it in there. And then basically what happens, like I said, air is being moved up the tube, so try not to breathe on this end, and then try not to have it like obstructed in any way. So just kind of let it hang. So calibration and scrubber. And we're probably gonna fail because of the sampling line, but we'll see. If you do fail the CO2 scrubber calibration, the first thing we really recommend is to try a different sampling line. If it keeps failing, then it could be the tube itself. But over time, the rocks will start to turn purple towards the end. It's like a really light purple. Once it's like a quarter of the tube purple, then it might be time to replace it. Which makes me wonder, how long have you guys had this?
Since we got the
Yeah, but it's been in this tube in the box, right?
yeah.
I'm wondering if that's why it hasn't like gotten purple. It's kind of weird.
So keep it in the box.
Yeah, keep it in the tube in the
Or
box.
the tube.
Yeah. And then I'll show you obstructing it. So just try to make sure it's not blocked in any way. There we go.
That's
No way. Oh, you know what? I think I know where it is.
Were you using a different sampling line?
What was that?
Was it a different sampling line?
No, I think at some point if you failed and you accepted it, then you could be telling the system that like it's okay at this environment. So I'm gonna reset that real quick.
It's fine. It's fine, everything's fine.
Just like a joke.
Basically.
And how do you prevent it from accepting? Like,
You can press or I think it's just an X actually. I don't even know if it's cancel, but just cancel or X, whatever it is. Yeah. And you can always restore the settings as well. What was that?
Yeah, how to reset it.
Yeah, I'll show you actually what I went into. Sorry, I probably should have shown you. But yeah, if you accept a failed one, just try to reset it. Into calibration, and then there's this little. It's called calibration factors. From here, you go into I think it's set defaults. Yeah. So set defaults, and then basically it'll confirm that you want to restore the factory settings, and you just click check, and that's pretty much it.
And you don't have to recalibrate the flow meter at this point?
Technically, yes. Since we just restored the factory settings, we're supposed to. But I'm going to go straight into the scrubber.
Okay.
Yeah. Unless you want to do it.
No, I.
Okay. Let me go ahead and go back and go into the scrubber. And I think we should fail in the scrubber. Now, since I just technically restarted it, it's telling you to do the warm-up. Oh, well, it'll ask you to do that as well. But it's telling me that we need to wait until we finish the warm-up. If that ever happens to you guys, if you had the K5 out for like 5 minutes, it's fine. The analyzers is still warm. It's just that the system is like, you just powered me on, you need to wait. This is basically what it's telling you.
What's the normal wait period?
So for a mixing chamber, if you're using a mixing chamber with a K5, it's a 30-minute warm-up. If you're doing breath by breath, it's going to be an hour. So either one of those are warm-ups. I'm going to go ahead and skip this and there we go. Oh my gosh.